Hi, Namaste, children. How are you? So, ready for the next one about graphs, important graphs for final revision. Shall we start?
గ్యాప్ ఇవ్వరా గ్యాప్ ఇవ్వు.
Okay, but revision time. Hmm? Let us start with graphs. What graphs are important for the final? And now, first chapter electric fields and charges. You know, variation of electric field with different systems. How does it vary with distance, including Gauss law applications? So here are some examples. Just go through. If you need, you can take a screenshot and you can save it to practice. Okay. And next, observe here the difference r square, r cube, how the slope should be different. Okay. Next, Gauss law applications. Going to second chapter, here also similar graphs. How does potential vary with the different systems? So that one essential. Okay, different things like solid sphere, conducting sphere, hollow sphere, insulating, everything. Going to next, current electricity. Here we have small graphs for short answers and a part of derivations like that. So just go through them, especially this one, Ohm's law. Remember here sometimes a misleading question can be there giving IV graph. You know VI graph more slope means more resistance. In IV graph the opposite happens, and also finding temperature from the graph. So you have to practice these things. Next, fourth chapter, moving charges. Here we have one 5 marks question, circular coil obviously, and one textbook question, cylindrical wire. Okay, so here are the graphs. You know, inside cylindrical wire, magnetic field is proportional to distance, and outside 1 by r square. And circular coil, maximum at the center and decreases with distance on both sides of the axis. So this one. Next, what the next chapter? Magnetism. Here we have very small thing, that is susceptibility versus temperature. You know how does it vary in paramagnetic? In diamagnetic it is constant with temperature. Okay, so these things practice well. And next, alternating currents. Here practice all the phasor diagrams, sir. I have shown some examples only here, but you have to practice all phasor diagrams. So you should learn all phasor diagrams, all voltage versus current diagrams, impedance diagrams, everything. Okay, some examples are here. And one more thing in this one is variation of reactance with frequency. XC, XL, how does it vary? Okay, you have to practice this one also. Now, this one, resonance related graphs. Okay, what happens at the resonance frequency, maximum current, minimum impedance? This one also is important. As a part of derivation also, you practice this one obviously. Next, array optics. In ray optics, V versus U, 1 by V versus 1 by U, you already did this in practicals. Okay, and the minimum deviation also is essential, prism diagram, correct? Going to next one. In wave optics, what is important here? How does intensity vary with distance or with the position on the screen? How in interference and in diffraction, you know the difference. Interference, it is constant intensity at all bright fringes. I mean, same intensity for all bright. Whereas in diffraction, different bright fringes have different brightness, decreases with order of the fringe. So you have to show that graphically. Okay. And going to the next one, jewel nature. What graphs are there in this? In this one, most of the things are graphs and highly essential. You have to practice each and every graph in this. I already told you during while talking about diagrams. Okay. And now, what are the important graphs here? First, current versus intensity, directly proportional. When intensity is zero, obviously current is zero. Next, how does it vary with potential? And how does current vary on potential depends on two things. Which is constant? Frequency constant or intensity is constant? So based on that, these two. And from these graphs, we can say stopping potential or kinetic energy is independent of intensity, and saturation current is independent of frequency. All these things we can obtain from this graph. Going to next one, stopping potential versus frequency. And here, observe the slope. What is the value of this slope? This one also is important for numerical purpose. Right, going to next one, atoms chapter. In atoms, you have alpha ray scattering, variation of these particles with angle, all these things. Just practice. That's not very important, but just practice once. So I'm going to the next one, nuclei. Binding energy curve is there. They're not asking binding energy curve to draw in the examination, but the knowledge of the curve helps you to solve some questions and also to get some information about behavior of nuclei. Okay, so practice that. Not exactly the shape of the graph, but just observe the information and analysis. And going to the last chapter, semiconductors. How does voltage and current vary with each other in a diode, Zener diode, forward, reverse, all these things. Okay, and forward bias and reverse bias, you can see the things in knee voltage, breakdown voltage, and the quantity of the current, how does it vary, all these things. And anyway, transistors topic was deleted, so we are not discussing about that. So these are the important graphs to be revised. And one important information for all of you. Our next video is coming on important numericals followed by sample question papers. Okay, we will do like all the possible sample question papers in these 2 days. So keep following, subscribe, and please press a like to this video if it is useful to you. Thank you very much, and please share it to your friends. Okay, all the best. Jai Hind.